Okay, I'm going to start by showing you what to do, how to integrate when you've got a chain rule situation. So there'll be a short first video of explaining the process, and then I'll do a longer video giving several different examples. All right, so remember if y is equal, say, x to the fifth plus 4 to the fourth power, this would be a chain rule, so the derivative, the 4 would come out in front, and then this would be 4 subtract 1, so it would be 4 times x to the fifth plus 4. So it's the derivative of f with the g inside, and then you take the derivative of g, or if it's a double chain rule, then it's one level further, and then you multiply that by the derivative of the g function, which would be 5x to the fourth. Then those two you would multiply together to be 20x to the fourth times x to the fifth plus 4. Some professors would maybe then have you do the distributive, but so that's just to refresh you on the chain rule. When you start off with the function, you find the derivative. Now, when we integrate, we're working backwards, so it's a little bit complex. So we're going to do what's called U-Substitution. You should already be familiar with that. And what you're going to do, everything below the exponent, that means everything inside here, that's what becomes the u function. So the u function is 2x squared subtract 5, and then we're going to take du dx. So the derivative of 2x squared is 4x, the derivative of 5 is 0, and then we're going to multiply both sides by the dx. And then notice, this thing right here matches that thing. So now, instead of putting 4x dx, we can substitute with du, and instead of putting 2x squared subtract 5, we can substitute with u. So now we can say u cubed du. All right, now when we integrate that, remember it's going to be u, 3 plus 1 is 4, divide 4, plus 0, and then when we integrate the 0, it becomes uppercase C. Look at what we have. We have u to the fourth, divide 4. But now, instead of u, we substitute back, and then the integral of 0 is the number. So that's the process. That is how you work backwards with the chain rule. All right. And then it gets more complex because, anyway, but that's kind of the gist. You figure out what the u is. You take the derivative of the u function, and the u function will almost always be whatever is in the parentheses, or in trig functions, well, it gets a little bit more complex, but I'll show you that when we get to a trig function. All right, that's it for just the gist of what we're doing for the chain rule, indefinite integrals.